This video is on discrete versus continuous functions. In a previous video called Graphing Relationships, we created the following graphs. We created a graph showing Angelica's heart rate as she exercised, a graph about going down a slide where we looked at the relationship between distance from the ground versus time, a graph on going down a slide, but this time comparing the speed at which we're rowing versus time. There was a guy who was filling a pool. He started out with 2 hoses, so it filled faster, and then he was reduced to 1 hose, so it filled slower. We had a problem where you eat 2 or 3 hot dogs every hour for 5 hours. And one about walking to the park. We measured your distance from home as time passed. And the last one we had was a problem about visitors to a national park decreasing every day for 7 days. So that would be this one here. Now, at the time of this video, I did mention that this last graph was the graph of a discrete function, and noted that it's made of dots. And the eating hot dogs also was a discrete function, because, again, it's made of dots. Well, the other graphs have a similar characteristic, or sort of an opposite characteristic. They are called continuous. A continuous graph is a graph that can be drawn without lifting up your pencil. So I can trace over Angelica's graph without lifting up my pencil. The slide graphs also are continuous because, again, you can trace them and you don't have to pick up your pen or your stylus in my case. So this is also continuous, continuous, continuous graphs. So a continuous graph is a line or a curve. So the points on the graph are so close together that they cannot be distinguished from one another. It's just a smear of points. And we're going to do 3 more examples. The first one, in the first one, you work at Kroger and you work in the click list department because it pays better. There's a little pro tip for you. You make $11 per hour, but you're 16 years old. Your shifts, according to Kroger rules, can only be 4, 5, or 6 hours long. So if you've been there for 4 hours, you have to clock out, if that's what you were scheduled for. 6 hours, you have to clock out. You can't work 4.5 hours or 5 hours and 15 minutes. That limits your shifts to the specific numbers 4, 5, and 6. If you work 4 hours, you're going to get $44 for that shift. 11 times 4 is 44. If you work 5 hours, that's $55. 6 hours will yield $66. So when we draw this graph, we need to label our x and y axes. So 1, 2, 3, 4, 5, 6. Notice even though 1, 2, and 3 are not part of my domain, I still have to count by evenly spaced numbers on my axis. And on the y-axis, similarly, I'm going to count by 11s, but I have to count by every multiple of 11 until I have what I need, 66. And then when I draw my graph, I go to 4, and then I bring it together with the 44. 5 is with, this is making my eyes cross, 5 is with 55, and 6 is with 66. Notice this is a discrete graph. The domain is the specific numbers 4, 5, and 6. Because the domain is specific, the range is also specific, 44, 55, and 66, respectively. Okay. Now, let's suppose when you turn 18, Kroger is a little bit less worried about how many hours you work. So you can work anywhere from 4 to 6 hours. They're not particular if you go over 10 minutes. They're going to pay you for that 10 minutes. So this time our domain cannot be listed because there are infinitely many numbers between 4 and 6, like 4.1 or 4.7 or 5.23. Your domain this time ranges from 4 all the way up to 6. Your range ranges from $44 all the way up to $66. Notice that I'm using inequality notation to indicate that there are infinitely many possible values. Now, to draw my graph, I still need to start with some guide points, so I'm going to label my x and y axes the same way I did last time. $4 hours results in $44. 5 hours with, oh, that's too low. 4 hours, $44. 5 hours, $55. 6 hours, $66. But because I can work anywhere between 4 and 6, I'm going to make anywhere between 44 and 66. This is now a continuous graph. Notice the domain is not a list of numbers. It's a spread of numbers. Now we're going to do one more example. This is a function expressed not as a story problem, but rather as an equation. Y equals the absolute value of x minus 2. Notice we're not given a domain. When you're not given a domain, then you have to think about what is a reasonable domain. Well, the reasonable domain here is all real numbers. Or, it's faster just to use that big capital R with the double back. So the reasonable domain is all real numbers. That means any number works. Now, I like to be systematic, so I'm going to start with -3, and I'm going to count upwards to +3. You can choose any values for x that you want. That's why x is called an independent variable. The y values that come out of this, well, absolute value of -3 minus 2 is +3 minus 2, or 1. Absolute value of -2 minus 2 is +2 minus 2, or 0. Absolute value -1 minus 2 is 1 minus 2, or -1. Absolute value of 0 minus 2 is -2. Absolute value of 1 minus 2 is -1 again. Absolute value of 2 minus 2 is 0 again. Absolute value of 3 minus 2 is 1 again. Just a reminder, absolute value takes away negative signs. So the absolute value of a number is always positive. I'm going to label my x-axis from 1 to -3 all the way up to 1 to +3, and my y-axis, let's see, +1 is the biggest number, -2 is the smallest number, and now I'm going to draw my graph. -3 is partnered with +1. -2 is partnered with 0. -1 is partnered with -1. 0 is partnered with -2. 1 is partnered with -1, 2 with 0, and 3 with 1. Now, if I leave it like this, I'm implying that it's a discrete graph. But the domain is not a list of these specific numbers. The domain is all real numbers. So technically, I could plug in -2.6 and get an answer. I could plug in 1.7 and get an answer. So I need to connect these dots with a smooth curve or line. Notice I want to be able to draw the graph without picking up my stylus. Now I can't stop there though, because I could have plugged in numbers smaller than -3 to the left here. I could have plugged in numbers bigger than +3, which means this graph goes forever to the right and forever to the left. So this is continuous, and the domain is all real numbers. This video was on discrete versus continuous graph. Continuous can be drawn without picking up your pencil, and discrete is a set of dots. Thank you for watching.